Today we take a look at solving number 26 on Leetcode, removing duplicates from a sorted array. Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. All right, so this is one of those in-place mutation array questions. Before we jump into code, let's do a quick visual run through. As you can see here, we've got a nums array with values 1, 1, 2, and 3. First thing we do is we initialize a variable called I. This is going to be used for our merge pointer. We set it to index 1. I'll explain that now. Then we start a loop also at index 1, and we use a loop variable called j. You'll see that I've color-coded these variables, and I've also added it onto the array where they're pointing to at this moment. Why do we start at index 1 and not index 0? Now, remember the question said unique items. Our first item is always going to be unique. It's only once we start working with multiple items that we can run into duplicates. The logic is simple here. What we do is we say, compare the value of j, where it is currently, with the previous item. So we do this, and then we loop on, and we do this, and then we loop on, and then we do this. Let's run through this whole array. J is currently at index 1. If we compare it with index 0, they're the same. So all we want to do is we want to loop on to the next item. Let's update these values. And now you can see where we're tracking in the array. Let's do it again. This value here, 2, is it different from this value, 1, in the previous space in the array? Yes, it is. Now all we do is we overwrite the value at our merge pointer. So that value is now 2. Let's update our values for our pointers here. That's updated. I is now at index 2. J is now at index 3. Let's do the logic. Is 3 different than 2? Yes, it is. So we want to overwrite it. So this value is now 3, and we want to update our pointers. Because we've used our merge pointer, we need to increment it. And we always increment our loop pointer. Our merge pointer now points to this index, and our loop pointer is out of bounds. Now, as soon as it's out of bounds, we return I, which says we've got 3 unique items in this array. And if you have a look at the first 3 items, they contain the unique set from this array. Let's go and do this in code quickly. So we need a safety clause in here, because remember we started our pointers at 1, which isn't a good idea if you've got an empty array. So let's just say if not nums.length, then return 0. All right. Now we say let I equals 1. Remember, that's what we're going to use for our merge pointer. And for let j equals 1, j smaller than nums.length. And we increment j on every loop. Now we go and say if nums j is different from nums j minus 1, the previous index, then, and only then, we want to go and use our merge index and set it to the value of the index at j. And only when that happens do we change the merge index. Lastly, return I. Let's give that a run. Accepted. Let's submit that. Accepted. Great. So that's pretty easy. You just need to know what to do. Let's talk big O for this one. In terms of time complexity, we've got O of n. Because if we send through 1,000,000 records here, we're just going to loop through it one by one. We don't have inner loops or anything like that that usually shows a non-O of n complexity model. And there you have it, another array mutation one where you have multiple pointers to go through the array and mutate it in place. I really hope that you get this one in an interview. I doubt it. It's a very easy one, but fingers crossed. As always, please like this video and subscribe to this channel.